Hi again, it's me, Michael, and we're going to be looking at sprint question number 20 from today's test 12403. So we have for how many non-negative real values of x less than or equal to 2024 pi is sine squared of x equal to secant of x? So we can see that we're looking for all values of x between 0 and 2024 pi inclusive that satisfy our equation here. Now, one quick thing to note is that we know that secant of x is equal to 1 divided by cosine of x. Note that this is not the inverse, but the reciprocal of cosine of x. So we can rewrite our original equation, which is sine squared of x equals secant of x, as sine squared of x equals 1 over cosine of x. Now, we can multiply both sides of the equation by cosine of x, and note that this does not introduce any new solutions in this case, because cosine of x cannot be 0. If cosine of x is 0, then secant of x is undefined, and sine squared of x never equals undefined, so that wouldn't work. So multiplying both sides of the equation by cosine of x gives us sine squared of x times cosine of x equals 1. Now, at this point, it may seem intimidating to try to find all of the solutions in this large range of possible x values, but we can remember, right, that sine x, right, and cosine x, right, both have ranges between -1 and 1 inclusive, which means that if we have sine squared of x times cosine of x equal to 1, that means the magnitude of both of them must be 1. That is, sine of x, has to be plus or minus 1, and cosine of x has to be equal to 1. Now, this is the case because if either of these are not true, then the product of sine squared of x and cosine of x can no longer be 1. Now, looking at this, right, do we ever have any values of x for which the sine of x is plus or minus 1 and the cosine of x is equal to 1? And the answer to this is no, since sine of x and cosine of x are offset by pi over 2 instead of any integer multiple of pi. And therefore, our original equation, sine squared of x equals secant of x over any interval of real value x has no solutions, which is answer choice B.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.